Another quite common programming assessment question is the container with the most waters. And the idea is you have some container, or I suppose like a jar or something, and there are bars that represent this jar, right? Or container, rather. And between those two bars is some amount of water that you can fill. And the question is between which two bars maximizes the amount of water that you can fill. And of course, as you see in example 1, between the second and the final bar, the last bar to the right, are the two bars that allow you to fill the most amount of water. And the problem seems quite confusing and perhaps even like too much going on to start with, but as we go through it, you'll see it's actually quite easy. It's quite intuitive to understand. Right, so the idea is that you have 2 pointers. All right, we'll call them I and j for now, 0 and len of height minus 1. So that is I is pointing to the first bar. If you see in example 1, the bar all the way to the left, and j will be pointing to the bar all the way to the right. And the algorithm looks something like this. First, we have to start off with some max volume, which is 0, right? And then we'll gather as we have volumes greater than that, we'll replace mx. Okay, so while I is less than j, okay, we have to move I to the right or j to the left, and that is how we're going to determine which of these two bars allows us to fill the most amount of water. Okay, so let's call H1 and H2 the two bars that are under consideration. We'll say height I and height j, height I and height j. Okay, so the next question is, well, how do we update our volume, right? Our max volume. Well, we say a max equals max of mx, so either max is bigger or the following is bigger. The minimum height between the two bars under consideration times their base, right? Base times height, because this is a two-dimensional problem. Also, that's something to consider here. We're not really considering the third dimension. That is not part of the requirements in the prompt. Okay, so this will update your volume. The next question is, which do we move, j or I? Do we want to move I to the right or j to the left? And here's how we're going to update that. We say if h1 is less than h2, h1 is less than h2, I plus equals 1. And the reason that we do this is that, well, if h1, the bar representing I, is lower or shorter than h2, right, then we need to go look for a bar that is higher than it so that we can find a way to maximize the volume under consideration. Else, j minus equals 1. In other words, h2 is less than or equal to h1. And that is how we will be updating our algorithm. We run, accepted, submit, outstanding.